This is Unit 1, Topic 4, an overview of ARC. Hello, and welcome to the BMC Quick Course series. In this module, we will discuss the usage and syntax of the ARC formatted checkpoint calls. The ARC checkpoint calls are one of several techniques that can be used by application developers to add checkpoint logic to programs. ARC provides three callable interfaces to enable checkpoint restarts in non-IMS programs. The ARC XRST call is similar in function and usage to the IMS XRST call that was discussed in the previous topic. The ARC checkpoint call is similar to the IMS checkpoint call, and the ARC E checkpoint call is a variation of the ARC checkpoint call with added parameters to enable further control over checkpoint processing. The ARC format calls provide checkpoint restart services for non-DB2 programs without requiring DB2 resources. As an example, a long-running vSAM update program would use ARC checkpoint calls to provide checkpoint restart capabilities. For DB2 programs that don't already issue SQL commits, ARC checkpoint calls are a simplified alternative to SQL commits. Whenever an ARC checkpoint call is issued, ARC will issue a DB2 commit on behalf of the program as part of the overall ARC checkpoint processing that will occur. It is important to note that DB2 programs that already contain DB2 SQL commit calls do not have to be retrofitted to convert to ARC checkpoint calls. Now let's discuss the ARC XRST call. The parameter list of the ARC XRST call is similar to the IMS XRST call, but is much simpler to use. The first parameter is a 12-byte checkpoint ID. During a normal execution of a program, the checkpoint ID will contain spaces. However, if the program is being restarted, ARC will provide the restart checkpoint ID. The application program can check for non-blanks in this field to determine if a restart is in progress. The application program should not update the checkpoint ID field. Following the checkpoint ID, the ARC XRST call supports up to 7 pairs of data names that identify portions of program storage that will be captured at each checkpoint and will be restored in the event of a program restart. To tag a portion of program storage, the developer simply inserts a data name at the beginning and the end of the desired storage location. For readability, BMC recommends using a naming scheme similar to this example. Now let's see how to use the ARC XRST call in a program. Here is a COBOL example showing the usage of the ARC XRST call. The ARC XRST call is inserted at the top of the procedure division. The developer can influence ARC restart processing, specifically when program storage is restored by the placement of the ARC XRST call. ARC initiates restart processing when the ARC XRST call is issued. BMC recommends the placements be very early in the program execution. It is very important to execute the ARC XRST call before any QSAM files have been opened. ARC only intercepts QSAM opens after the ARC XRST call has been issued. Any opens issued before the ARC XRST call are ignored by ARC. The developer wishes to ensure that the variable page count does not reset to 0 after a restart, so that variable has been tagged on the ARC XRST call. This will cause the value of page count to be snapped off at each checkpoint. In the event of a restart, page count will be reset to the value as of the most recently completed checkpoint. The begin WS1 and end WS1 variables have been inserted to identify the storage location to ARC. Notice that the checkpoint ID field was not included in the saved area of program storage. This is a field that is managed by ARC, so there is no need to capture this storage. The program simply tests the value of checkpoint ID to determine if the program is being restarted. In this example, the program simply issues a message indicating that a restart is in progress. Now that we have covered the ARC XRST call, let's see how checkpoints are processed. ARC checkpoint processing has a much larger scope than either IMS checkpoints or DB2 commits. This is because ARC includes non-DBMS related program components in contrast to the IMS DB2 alternatives, which only focus on DBMS related components. ARC provides two types of checkpoints, the ARC checkpoint and the ARC E checkpoint. The ARC checkpoint call is the simplest to use as it requires no parameters. There is no need to check the status code of the ARC checkpoint. If the checkpoint failed to complete successfully, ARC will abandon the program. The ARCE checkpoint call provides additional levels of control to the developer through the use of the Application Request Block, or ARB. Specifically, the ARCE checkpoint allows the developer to override the effects of checkpoint pacing by moving a value of force to the function code variable. This causes the pacing filters to ignore the checkpoint request and allow it to pass through without any interferences. Be sure to reset function code back to spaces after the checkpoint has been completed. After the ARCE checkpoint call, the program must test the status code to ensure that a successful checkpoint was completed. Both forms of checkpoint will generate a DB2 commit for programs running under DB2. This simple program logic shows how to use the ARC checkpoint call. Notice that the program is trying to issue an ARC checkpoint call for every 500 input records. If this is a DB2 program, a DB2 commit will be generated by ARC as each ARC checkpoint call is processed. The developer has chosen to issue a final checkpoint at program shutdown time. This is an optional technique to ensure that all files have been closed and no residual data is left in any buffers. This technique assumes that checkpoint pacing is not active. Otherwise, there would be no way to ensure that the checkpoint was actually allowed to pass through the checkpoint pacing routines. This program logic illustrates the subtle differences involved when using the ARCE checkpoint variant of the checkpoint call. The most important characteristic of the ARCE checkpoint call is its ability to override checkpoint pacing from within the program. The layout of the ARC ARB is provided in this example for your reference. As a final reminder, you cannot use ARC XRST, ARC checkpoint, or ARCE checkpoint calls in an IMS program. You cannot mix the ARC checkpoint and ARCE checkpoint calls in the same program. You must use one or the other. This concludes this section of ARC checkpoints. For more information, visit www.bmc.com. Thank you.